Okay. So my name is Emily. I'm here with Fuel Labs. And today we'll be doing a workshop on developing your first smart contract using our language Sway. So I'm hoping that today we can do a fairly interactive workshop. We have a bunch of the Sway team here with us. Sway team, please raise your hand. So I think it would be really fun if we could do something interactive while you all have the opportunity to have the team here in the room with you and get to know us, get to know the tool, get to know the language. So we'll do a little intro about what is Sway, a little intro about how to use it, and then we'll dive into the workshop. So can I see a raise of hands of maybe how many people have their laptops and how many people might be following along on their laptops today? Just to get a gauge? Okay. So in that case, I'll also be working on the screen so that everyone can see what I'm doing and can get a feel for the language as well. What is Sway? Sway is a blockchain language that is used for developing smart contracts. It is written for the Fuel ecosystem, and it takes from both Solidity and from Rust. So from Solidity, it takes a lot of the blockchain-focused design elements that you might be familiar with. So you can call contracts, you can write smart contracts in general, you can have contract storage, and more. And then from Rust, it takes a lot of the general language design, and it takes a lot of the design principles, the general feel, the ergonomics, and the developer experience. So when we're designing Sway, we're really hoping to kind of couple the two benefits of the two languages, so offer you the ability to develop for blockchain while also offering you the awesome benefits that Rust provides both in its ecosystem and its user experience and its feel. Sway is the language that is used on the Fuel network and the Fuel virtual machine. I won't get into that too much today, so if you're interested in learning more about Fuel and the benefits of Fuel, you can go to our website, fuel.network. It's a little bit light on this screen, but the website is just fuel.network, and you can learn more about the Fuel VM and the Fuel ecosystem. Just in broad strokes, the Fuel ecosystem, you can think of it as part of a modular blockchain, so it's a modular execution layer, and its main goal is to do execution with the Fuel virtual machine using highly parallelizable UTXO-based transactions with the smart contracts written in this Sway language. So we'll be learning Sway today, and then the contracts that you'll be writing will be executing on the Fuel VM on the Fuel ecosystem. So for the people following along, there's 2 installs that we need to do right off the bat. And so we'll get those started, and then we'll dive into the primer about Sway. So the first one is installing cargo. I'll just pause for a few minutes for everyone to install cargo. I don't really know how long to wait, so I feel like, is everyone, the people that want to install cargo, have y'all installed cargo? Okay, I will take that as a yes. So then the next thing is you will need to install Fork. Fork is the project and dependency management system for Fuel, and you'll install it using FuelUp. FuelUp is very similar to RustUp, which is used to install Rust and cargo. So you'll install it with this. I just made a tiny URL for it. The install for this one takes a few minutes, so we'll just get this one started and then proceed with the rest of the slides. Again, I'm not really sure how long to wait for this, so if you still need this, let me know and I can go flip back to the slide. While this is installing, I'll just do a quick 5-minute primer about Sway, and this will give us enough information to where we feel like we can dive into learning how to write our first Sway contract. So when you're working with Sway, there's of course the language itself, which is Sway. The language has syntax, it has its design, but then you need to be able to use it. You need to be able to build it, compile it, deploy it. And the way that you're going to do that is with Fork. Fork is the project and dependency management system for Sway. You will use Fork to compile, build, deploy, and test your contracts. You'll use it to start local field networks and more. So that's what we installed on the last slide. To give you an example of what Fork can do, when you want to create a new project, you can use Fork new, pass it a name, tell Fork that you want to create a new contract, and Fork will create a new empty contract for you. So we can see here that Fork has created a skeleton contract structure for us. And at a high level, every Sway project has 4 components. It has the cargo.toml, fork.toml, the source directory, and the test directory. And I'll describe what each of those means. So the fork.toml file has all of the information in it that Fork needs to build your Sway project and deploy the contract. So this is like the name, the dependencies, the version, information like that. Then the source directory has the contents of your Sway code, and the main.sway file is the entry point to the project. The test directory has your Sway tests, and you'll see here that the test directory has a harness.rs file, so that you may notice that this is a Rust file, and that's because in a Sway project you can do testing with Rust. You can write your tests in Rust using the Fuel Rust SDK. So the Rust SDK allows you to do all the things that you would do with Fork, so compile, deploy, test Sway contracts, and it also allows you to spin up a local field network and more, all in Rust. And that leads us to fork.toml. Essentially, Fork uses cargo under the hood, so the cargo.toml file helps Fork understand how to build this project. To build a Sway project, you can run fork build. We can see here that we've built our project successfully. And then to run the tests that I mentioned on the previous slide, you can use fork tests. Now we'll talk a little bit about the language definition of Sway, which will help us understand what we'll see in the example. In Sway, you can have variable declarations. So to declare a variable, you will use the let keyword. To declare a mutable variable, you use the mute keyword, and then you can also add type ascriptions with this type ascription syntax. You can have functions. So here we have our function called function name with our two parameters, param1, param2, and it returns a string of length 4. In a Sway contract, you define the ABI and then implement the ABI for the contract, and it's done as such. So you will define the ABI using this ABI keyword. So here we have our ABI called simple auction. The ABI has one function bid, and then we implement the ABI for contract, and we implement the contents of our one ABI function bid with the body of the function. This is beneficial because this means our ABI definitions are exportable and shareable. So in this particular example, the ABI definition is co-located with the implementation, but with a Sway contract, you could potentially separate the ABI definition from the implementation, and you could write a Sway library that has the ABI definition, and you could make that library shareable, and you could implement multiple contracts using that same library, and you could share that library with your friend, and your friend could write their own contract using that same ABI definition, and it allows you to really expand the scope and make those ABIs shareable. Sway has contract storage, and contract storage is accessed using the storage keyword. So here we have the storage keyword, and in this example, we have one element in our contract storage called myData, which is a U64 initially set to 0. To access contract storage, you need to create a function, and above that function, you need to annotate it with this special annotation here. This annotation tells the Sway compiler that you want to both read from storage and write from storage. This allows the compiler to make certain guarantees and optimizations and perform efficient auditing. To access storage, you use the storage dot syntax. So here we can say we're retrieving our old data, we're saying storage.mydata, setting it to a variable, and then we're updating storage.mydata with the new data, and then returning the old data. Expanding on this idea, Sway also offers a mapping type for storage called storage map. So here we have our storage, our contract storage again, and we have the mymap variable. And the mymap is a storage map mapping a U64 to a Boolean value. So you can think of this like a number to if that number is on or off. And it's initially set to an empty storage map. If we want to insert a number into this map, we can use the annotation of write, and we can say storage.mymap.insert with the number we passed in and the on or off Boolean. If we want to get from the storage map, we can use the annotation storage.read, and then we can say storage.mymap.get with the letter n for the number that we've passed into the function. So that's just a high-level overview of the design of Sway. If you wanted to know more about the design and get into the details about, we also offer generics and type inference, enums, structs. If you're interested in learning more about that, you can go to our website, fuel.network, and we have a Sway book. There's also we have several talks coming up later today. Alex has a talk at what time? 5:40. At 5:40, across the hallway, where he'll be talking about the advancements that Sway has come from in the last year. So that'll be exciting. Okay, so now for the meat of what we'll be looking at in the workshop, building our first contract. So when we build our first contract, we'll be building a contract that will allow us to vote. It'll allow a group of users to vote on what their favorite number is. So you can think of it kind of like a DAO, where the DAO is just voting on what the user's favorite number is. It'll be a little different from a DAO. It'll be a little limited, and we'll see that in a second, but you can think of it kind of like that. So at a high level, we'll be writing two different Sway smart contracts that'll be interacting with each other. One will be the governance token. That'll be a very simple contract. And the other one will be the actual voting contract that'll have the logic for adding governance tokens, depositing them, withdrawing them, and voting. We'll also be using fork to build and test our contracts. Okay, so if you're interested in doing this on your personal machine, you can go to this website and download the repo and follow along. There's like instructions for how to follow along and a skeleton code for how to implement it. But it seems like a lot of people are on their phones, so I'm wondering if it would be a good idea to ad-lib some live code. Yeah, okay, I think I'm gonna ad-lib some live code, which I've never done before, so please bear with me. And nor did I plan for this, but I'm really hoping that I can give y'all a feel about what it's like to build with Sway. So I'm gonna set this down and start yelling. Okay, so if we go to, can y'all hear me? Yeah. Okay, so if we go to this GitHub, it'll point us to.
Yeah, you need to keep closer. Like.
Oh, I'm gonna be coding.
Yeah, but when you talk, for the recording.
Oh, okay.
You won't get you so much.
Is setting it on here okay? Yeah. So I have to hold that and then.
No, it's okay. You can cut, but I can hold this.
Oh.
Yeah,
Oh, okay.
I
Okay.
like
Oh, okay. Okay. Thank you. Okay. So,
Can you quote it about hand? Really?
Allez, c'est vite là. Vous avez pas un truc hein? Yeah.
Yeah.
If I do like this.
Yeah. That should work. I'll just talk loudly too. Yeah. Yeah. Okay. Oh, perfect.
Celui-là, ça marche, tu crois? Attends, fais attention parce que là, je peux pas. Faut faire attention. Tu le tiens?
Ouais, c'est bon.
Ok.
Non, non, mais c'est pas lui. Non, c'est pas lui, mec. Passe-moi. Ouais, mais il a pas de.
All right. Yeah. All right, let's do this. Thanks, y'all. Okay, so when you go to the GitHub, you'll come across this repo. So you can either follow along now or you can follow along later, but it has some resources in it that will help you get started. So to start off with, it has this cool README with a description about what we're doing. We're building this voting contract that allows us to vote on our favorite number. It has some steps about how we can get started, getting set up, setting up our editor, the two contracts that we're writing, that token contract, that voting contract, and then some ideas for how you can work on this contract going forward and expand it. So it also has a skeleton project to get you started, where you can just fill in some functions, and then it has a solution for you to check your progress. And today, live, we'll be filling in the skeleton project and doing it and discussing the SWAY code together. So I have this on my machine. Okay. Okay, so here's that exact repo that we saw on GitHub, but just in VS Code. To start out with, we're going to build the token contract. So this is our governance token that our users are going to use to vote in the contract. So what they'll do is they'll use the governance token to deposit in the contract, and then once they've deposited the tokens, they can use those to vote, or they can withdraw their governance tokens if they don't want to vote anymore. Starting out, we'll go into our source directory that has our SWAY file. And we see that in here, we have a couple different items. So at the top of every contract in SWAY, there's this contract declaration. This is just telling the SWAY compiler that we're looking at a contract. Next, we have our dependencies. I won't dive too much into the module system and the dependency system that SWAY has, but you can think of it as being very similar to the Rust module system and dependency system if you're familiar with that.
Could you speak a little bit louder?
Yeah. And then next we have our ABI definition. So this ABI definition looks similar to the one that we saw in the slides. It has one function. So the ABI is called myToken with the function mint and send to address. This function will mint the token and send it to the address that we provided. Here we're implementing the myToken ABI for contract, and we have this skeleton code that we're going to be fixing so that we can actually mint it and send it to the address. One of the benefits that SWAY provides you is that SWAY provides a very extensive standard library. The standard library has a bunch of different data structures that allow you to build your blockchain applications. One of these, and a bunch of different functions that allow you to build these blockchain applications without having to, reinvent the wheel. We've done a lot of the heavy lifting for you and provided you with those building blocks already. One of those is the function mint to address that's coming from the standard library. So the mint to address function does what it says. It mints a token, and then it sends it to the address that you've provided. So we will call this function mint to address with the amount that we're passing into the ABI function, which is just called amount. And then in our to field, we will pass in the recipient, which is the recipient in the ABI definition. And that's it. That's all we have to do to write a contract with that mints tokens and send them to users. Okay. Hopefully this doesn't get confusing, but here we have VS Code, and then when I flip over, this is just the terminal with the same repo. So now we're inside of that token contract that we just filled in, and we're going to build this using fork. We're going to call fork build. Oops. Oh, and see, okay, so we called fork build. Fork build gave us a compiler error, and this compiler error is giving us a message about what's wrong. It's saying that it's an unexpected token in this statement, and this error message is telling us that we're missing a semicolon right here. So we can go back and add this semicolon, save it, and run fork build again, and we see that fork successfully builds the Sway project. So that's all we have to do to build our first Sway contract. Okay, now we're going to build the contract that does the voting.
Sorry, can I ask just a quick question?
Yeah.
You always going to say that it was correct sending, you always send it to true. Shouldn't you send the result of this mint to address function?
I'm sorry?
You always send in the true of the function mint to address, yeah? You always send that your contract was executed successfully. Shouldn't you apply with the mint to address result function?
Oh, I didn't hear you say that. Can you do it the...
Yeah. So my question is that you're constantly finding fixed true result of the execution function. Shouldn't your response with mint to address result?
Oh, instead of just saying true?
Yeah.
Oh, yeah.
Makes sense.
Oh, so this is just like a toy example.
Yeah.
In an actual example, you would want to check to make sure that this returns an accurate result and then do something really different. Yes, that's correct. Okay, so now we're going to take a look. Oh, and please interrupt me if there's any questions, if y'all are lost. I really want this to be as interactive as possible, so let me know if you have any questions. Okay, so now that our token contract is done, we're going to write our contract for voting. Our contract for voting has 3 different files. It has our library file, which has the ABI definition. It has the error file, which is going to help us do error handling. And it has our main file, which has the implemented ABI definition for our contract. So we're going to start out by looking at the ABI definition first. The ABI definition has several different functions. It has an initialize function, a function that gets the balance of the contract, a function that gets the balance of particular users. It gets the current favorite number, gets the number of votes for a particular number. It allows you to deposit coins, allows you to withdraw or deposit tokens, allows you to withdraw tokens, allows you to vote, and allows you to execute the voting schematic and count the votes and set a new favorite number. So inside of this library, we've also provided like a sense of state. So Sway has structs and enums, and here we see an example of an enum. So an enum, you can think of it like a sum type. So in this enum state, it's either like a non-initialized state or it's an initialized state. And when you have a variable that's of type state, you can check to say, okay, is my state non-initialized or is it initialized? And we're going to use this in our contract to check to see if we've run this initialized function here. Because the way that we're going to implement it, we don't want to have users like voting if we haven't set up the voting system yet. And we'll see that in a second. Okay, so there's a lot to talk about here, and we'll just go through it step by step. At the top is our contract definition that we saw in the previous example. Then we have our dependencies and use statements. Again, I'm not going to get too much into this dependency system, but you can think of it similar to Rust's dependency system. Here we have a constant value. This constant value will be used to determine the maximum value of the possible favorite number. So in this particular example, the favorite numbers users can vote on are between 0 and 99 inclusive. So they're not able to vote on 100, but they can vote on 0 to 99. Yeah?
What's the difference between just let and const? There was a difference between const and let.
Yeah, const is a constant variable, so it's not able to be mutated, and it has special properties inside of the compiler. So for instance, it will be able to be, Sway has match statements, and it will be able to be used in a match statement. You will be able to match on a constant versus you will not be able to match on a dynamic value because that dynamic value will change. Yeah, Alex.
Awesome. Also, constants are global, but lets are all scoped to the surrounding scope. But a constant is always global.
Yeah.
And so that's the difference between let and let mute, right? Because you had let and let mute before.
Yes.
So yes, my question was mostly between constant let and let mute. But then it's clear. Thanks.
Yeah. Okay, we have our contract storage. There's the state, which is that initialized or not initialized value. We're starting it off as non-initialized because we haven't initialized our contract. We have our contract ID of the governance token that's going to be used to allocate our votes. Yes?
Do you have to annotate constants, like in Rust? You have to say like the maximum is like a u size or, you know. Do you want me to repeat it?
Yes.
Oh, do you have to annotate constants like you do in Rust?
No.
So like in Rust, if it's a number, you would have to annotate it to be like u size or u32 or whatever. Okay.
No. We're going to keep track of our current favorite number in contract storage. We're going to keep track of the current number of votes for each prospective favorite number. And we're also going to keep track of the balance for each user. So this is the number of governance tokens that they've deposited into the contract. And here's where we're implementing that voting ABI from the previous file for this example. Before we get into implementing it, I'm going to show you how we're going to be thinking about this problem. So if we go into the voting contract, we can build it, but we can also run tests. So what I've done is I've already pre-written a couple tests for this project that are going to help us drive development. And these tests, they all fail because none of our functions are implemented yet. But these tests are going to help us think about the project and think about how we want to implement our functions. So the tests are, can we deploy and initialize the voting contract? Can multiple users vote? Can multiple users vote and execute to find a new favorite number? So as we're building today, we will be seeing these tests start to pass. I just want to check the time really quick. Okay. Okay, so we're going to start out with and just implement the initialize function. We have a couple to-dos. The first to-do is we are going to set the storage token variable to the token that we passed into the contract. And to do that, we're going to use the storage dot syntax. So we'll say storage dot token equals token. And then number 2 is we're going to set the storage state to initialize because we're calling the initialize function. Storage dot state equals state initialized. And then lastly, we're going to insert values into the storage.number votes from 0 to max num using a while loop. So I'll write that for us. So we'll say let mute I equals 0 while I is less than max num, I plus equal 1. And we'll say storage dot number votes insert I 0. So this will insert into our number of votes for every number. It starts out with 0 votes. And we'll go ahead and run this. So when we're running fork test actually runs fork build under the hood before it runs the test. So during this exercise, I'm just going to be running fork test, and just know that it's running fork build under the hood for us. Okay, so we can see here that one of our tests passed. Well, actually, 2 of our tests passed. So the tests that pass are the deployer can initialize the voting contract, which is good because we just wrote the initialize function. And we also see that the deployer can mint function pass, which is good because in our previous contract, the token contract, we wrote that function that calls mint to address. So what this is saying is right now we're able to mint our governance tokens and we're able to initialize the voting contract. Yeah.
Question. I see a while loop over here. Do you guys support for loops? Let me ask that question. I see a while loop over here. Do you guys support any sort of for loops?
It's on the roadmap, but we don't currently have them in the language.
Thank you.
Yep. Okay, so here we have some getter functions, so we can get the current balance of the contract. This is a standard library function that gets the balance with the token that we pass in. So this will just get the contract balance of the governance token. This is a getter function which will get the balance of our particular user. So here we have another standard library function called message.sender. Message.sender will return the identity of the user or the contract or the address that's called the contract that we're in right now. So in our tests, when we run fork test, we can think of these like users with wallets and people that are executing this contract. And when they're executing this contract, the message.sender function from the standard library is retrieving their identity, and it's allowing us to create a unique user for them. You can think of it like a B256 value, and it's allowing us to create that unique user and insert their unique user value into the user balances storage map. Importantly, message.sender returns like a special result type, which you can think of as a special error type. So in order to handle this special error type, it needs an accompanying function called unwrap, which allows us to access that identity. Another get function, which allows us to get the current favorite number. Oh, thank you. Great. Yeah, thank you. Okay, time to implement another function. So now we're going to implement the deposit. Oh my gosh. Okay. Now we're going to implement the deposit function. This function is going to allow users to deposit governance tokens into the contract. Then with those tokens, they'll vote for their new favorite number. So there's a lot of to-dos here, but we'll take them one at a time. So the first to-do is get the identity of the user that called the contract with the function using the message sender function from the standard library. We actually saw that up here in our get user balances. So for the purposes of this, we'll just copy this and we'll say, okay, we're going to get our user with the standard library function message sender, and we're going to unwrap that to retrieve the identity. Then we're going to get the amount of the deposit with the function message amount. So we'll say our amount equals the message amount. Then we will get the previous balance of the user from our storage.userBalances. So we'll say our previous balance equals our storage.userBalances.get, and we'll pass in the user. This is because we've been indexing our user balances with this user identity. Next, we will calculate the new balance using the values from step 2 and step 3. So we'll say our new balance equals our previous balance plus the amount that we're depositing. And lastly, we'll update the user balance using the storage.userbalances.insert. So we'll say storage.userbalances.insert with the user and the new balance. Okay, so this is great, but there are a couple things to consider. So one, what if the user tries to deposit a token that's not our governance token? Well, they should probably not be allowed to do that. Or what if they try to deposit 0 tokens? Well, they should probably not be allowed to do that either. In order to accommodate these cases, Sway provides some error handling methods. In this particular example, we see an instance of the error handling method here called require. Require takes 2 arguments. It takes a conditional and a value. And it says, okay, I want to require this conditional to be true. And then if it's not true, I'm going to revert with this value. So at the beginning of each of these functions, I've already provided that I want to require that the state is initialized. And if it's not initialized, I'm going to return this error that the contract is not initialized. But we could expand on this and say, I want to require that the amount that the user is depositing is above 0. And if it's not above 0, I want to return an error saying that the value is not above 0. Or I want to require that the user is depositing the correct governance token. Just so that we can speed up the example, I'm not going to go into that, but just know that you could do that in your own time later if you wanted to. Okay, so now we're going to run the test again and see if we've successfully written the deposit function. Cool. Okay, so we can see that the user can deposit, which is great. That means we've written the deposit function successfully. I'm just going to check the time again. Okay. All right, now we're going to write a function that will allow the users to withdraw governance tokens. Again, there's a couple to-dos, but we'll go through them one by one. So the first one, get the identity of the user. We know how to do this from the previous one, so I'll just copy this. We'll get the identity of the user. Get the previous balance of the user from storage.userBalances. So we'll say let the previous balance equals storage.userbalances.get user. Step 3, calculate the new balance using the values from step 2 and the amount to be withdrawn. So we'll say let the new balance equals the previous balance minus the amount to be withdrawn. Update the user balance using the user balances insert. So we'll say storage.userbalances.insert, giving it the user and the new balance. And then we'll transfer the asset that we're withdrawing back to the user using the transfer function from the standard library. And the way that we're going to do that is we're going to use this function transfer We're going to pass it the amount. We're going to pass it the asset ID, which is the storage.token, which is our governance token. And we're going to pass it the user that we've retrieved, which is just user. Yes?
So does the transfer function, which currently has a typo, is that transferring a token from one contract to another?
Yes, yeah.
So in Ethereum and Solidity land, this usually requires an initial approve and then something like a transfer from. This appears to not require an approval. Is that an intentional design choice?
Yes.
Could you expand on that if you could?
So I mean, from a design perspective, a lot of the design decisions of Sway are made for ease of use and developer experience. So by providing much of the standard library and by providing the way that we've designed the Fuel VM, much of the components that wrap a transfer that you would need to do in Solidity are just kind of put as guarantees in the compiler underneath the hood. So there's, and when I'm saying that, it's a broad spectrum way of saying some of the things that you would be used to seeing in Solidity are things that are allocated to the standard library, but they're also some of the things that are guarantees by product of the design of the Fuel VM. And that's manifesting in the fact that to transfer an asset, you simply have to call the transfer function. Okay, so again, what if the user wants to withdraw more governance tokens than they've deposited? We certainly don't want them to do that. And to prevent them from doing that, we would write a require statement to require that their previous balance is the same or greater than the amount that they want to withdraw. But for the purposes of this exercise, we're not going to do that. We're just going to trust that all of our users are good actors and they don't withdraw too many tokens. So we'll test this with fork test. And we see that users can deposit and withdraw, which is great. Check my time. Okay, so we have about 10 minutes left, so we have time for one more function, and then I'll just wrap it up for questions. So the last function that we'll write is vote. And for vote, the users will take their deposited governance tokens and they'll allocate them to the number that they want to vote for. Okay, oops. So first thing we do is get the user, which we've done before. So we'll just copy this. Okay, get the previous balance of the user. So we'll say like previous balance equals storage dot, oops, user balances dot get with the user. Okay, calculate the new user balance using the value from step 2 and the vote amount. So we'll say the new balance equals the previous balance minus the vote amount, because the user is spending their tokens to vote. Update the user balance using the new amount. So we'll say storage.userbalances.insert with the user and the new balance. Okay, now we're going to get the current number of votes for the number that the user is voting for using the storage.number of votes. So we'll say current votes equals storage.number votes with get and the voting for number argument. Then we'll calculate the new number of votes. So we'll say new votes equals current votes plus vote amount. And then we will update the number of votes to our new number of votes. So this will be our storage dot number of votes insert with our voting for number, oops, and our new votes. Okay, so this is taking the amount that the user is passing in that they want to allocate towards a vote and the number that they want to vote for. It's retrieving those tokens from the user's balance and allocating them towards the number that they want to vote for. Again, we should consider when they don't have enough tokens, if their balance is not high enough, but in this example, we will bypass that. So let's test this. And we see that a bunch more tests pass because now users can vote. So the users can vote test pass, multiple users can vote, and users can vote for multiple numbers all pass. So the tests that are still failing are the tests that require us to execute the votes and update the current favorite number. Unfortunately, we don't have time for that today because I want to wrap up with some concluding statements, but hopefully I've piqued your interest enough to where you can finish that last function on your own. Okay. So today we covered what is Sway. It's a language for building smart contracts on the Fuel ecosystem and the Fuel virtual machine. We talked about how to get started with Sway and Fork, and we wrote our first smart contract in Sway. To wrap up, I want to plug our new grant program that we have available. So Fuel is running this grant program. If you're interested in using Sway, using Fork, and learning more about Fuel, you can apply. Applications are open right now. We have anywhere from 10 to 150 USD available. We are excited for people to get interested and get moving with Sway and start developing. Thank you all so much. There's QR codes, so the one on the left is the form for the grant, and the one on the right is the Twitter. I'm happy to answer any questions. If anybody wants any more resources, please let me know. Thanks you all so much.